Allan Chapman looks at the man who discovered it in The Great Scientists.
In the ancient world, people believed the Earth was at the centre of the universe and the stars and planets were somehow fixed in place in the heavens. But by the 17th century, most astronomers had realised this wasn't true, raising some perplexing questions. How do the planets float in empty space? What is the glue that holds them in their orbits? And what on earth has this got to do with an apple falling from a tree?
Welcome to Great Scientists. Tonight I'm going to be talking about the life and career of the legendary Sir Isaac Newton.
Newton was born into a world on the brink of a scientific revolution. And although scientists had made a number of interesting new discoveries, they still didn't understand what basic physical forces held the universe together.
The solution to that problem would immortalize the name of Sir Isaac Newton.
Isaac Newton was a brilliant mathematician, a biblical scholar, an astronomer, and an inventor. But his greatest contribution to science was his discovery of a set of universal laws to describe the cosmos.
Cambridge University is justifiably proud of its illustrious old boy. But when he studied here, science was very different from what it is today.
In Newton's time, the study of the physical world was known as natural philosophy. But Newton's pioneering work would lead him to be seen as the father of modern physics.
In middle age, Newton became a difficult and a rather disturbed man. But perhaps the seeds were sown in early life.
Isaac Newton was born on Christmas Day, 1642. A tiny and weak child, he seemed unlikely to live. His mother left to marry a 63-year-old clergyman. Brought up by his grandparents, Newton grew up a lonely and unpopular child, often fighting and causing trouble. As a young man, he was obsessed with inventing and building things. He was particularly fond of making sundials, which were his preferred method of telling the time. At the age of 17, he was brought home from school to manage the Woolsthorpe estate, but he was rubbish at it. Fortunately, his headmaster recognised his talents, and Newton prepared for university life by buying some simple necessities: ink, candles, a notebook and a chamber pot. And so it was that he set off for Cambridge. However, on arriving at the university, he soon had a religious crisis and made a long list of his sins, including baking cakes on a Sunday and sneaking a piece of cherry pie.
Bloody hell. Wasn't that terrific? Isaac Newton came up here to Trinity College, Cambridge as an undergraduate in 1660, where he found, surprisingly, that the curriculum was still dominated in the sciences by ancient philosophers such as Aristotle.
Many academics at the university were still teaching ideas that had originated over 2,000 years previously in ancient Greece. And despite the work of scientists such as Galileo, many of these ideas had never been subject to scientific scrutiny. There were, however, a number of Newton's contemporaries who were starting to conduct experiments to test these ideas. And these men were to encourage Newton's own rigorous approach.
Isaac Newton was influenced and inspired by many of the men of his age, though he rarely ever gave them much acknowledgement. But perhaps the most influential of all of these figures was Dr. Robert Hooke.
Here, at Wadham College, Oxford, Robert Hooke worked with a group of men who would later become the Royal Society. The Royal Society, of which Newton would eventually become president, played an important part in spreading information to the middle classes. And soon it was considered to be part of a gentleman's education to know something about gravity, telescopes and air pumps. They organised very practical demonstrations aimed at debunking popular myths and superstitions. For example, one ancient belief held that spiders could not cross a barrier made from the horn of a unicorn. Lacking a unicorn, powdered rhinoceros horn was placed in a circle and a spider solemnly placed in the middle. Curiously, the creature crawled out straight away.
Although Cambridge didn't have an active experimental tradition at this time, Isaac Newton realised that you can't just claim universal laws. They have to be subject to observation, rigorous testing, and mathematical proof.
Newton is best known for his work on gravity, but his first great fascination was with another fundamental problem in physics, the nature of light. How, he wondered, could pure white light produce so many colours? Where did they all come from? This question had puzzled scientists for thousands of years. Whilst at university, he began to conduct experiments on himself, sometimes taking things to dangerous extremes. He is said to have stared at the sun until he was forced to lock himself in a darkened room for several days. On another occasion, he forced a large blunt needle between his eye and its socket to see what effect it would have on his vision. He nearly went blind. But it was with a pair of simple glass prisms that Newton devised his most famous experiment into the phenomenon of light. At the time, people knew that light passing through a prism created a rainbow effect, but most people believed that the shape of the glass somehow tinted the light. What Newton would show was that in fact colour was already present within the light.
Welcome to the laboratory. Today I'm going to be looking at that experiment which Sir Isaac Newton called the wonderful phenomenon of colours. Now, from ancient times, scientists have believed that all light was white because it came from the heavens, and only became coloured by contamination with earthly things. The first scientist to challenge this idea was Robert Hooke, the curator of experiments at the Royal Society, and his researches led him to conclude that light was in two colours, red and blue, and the intermixing of these gave all the colours we have in nature. But Newton was to take these experiments further, and he did this, first of all, by purchasing a pair of prisms at a Cambridge fair. And so it was that with a pair of simple glass prisms, Sir Isaac Newton constructed a highly illuminating experiment.
In his room in Cambridge, Newton allowed a narrow beam of sunlight to pass through his window shutters and enter the prism. This projected a small spectrum of coloured light against the wall. Unlike his contemporaries, Newton felt certain that all of these colours were already present in the white light and were simply being separated by the prism. Using a piece of card with a small hole cut in it, he discovered that if he only allowed one colour from the first prism, for example the red, to pass through the second prism, it was impossible to split it into further hues. The light simply stayed red. In this way, Newton had finally proved that white light was in fact made up of colours that were distinct entities.
It's hard to overstate the revolutionary importance of what Newton said when he claimed that white light was a combination of different colours.
Armed with his knowledge of how light works, Newton set about designing a new kind of telescope. The trouble with traditional telescopes was that imperfections in the glass lenses refracted the light and distorted the image. Newton realised that he could get around this by using mirrors instead of glass lenses.
This therefore led him to make a mirror, concave, curved out in the middle. And this mirror could focus the light just like a lens. And the great beauty of that device was, it was distortion-free.
Newton polished his own metal mirrors, and although his telescope was only 6 inches long, it achieved the same magnification as others that were 6 feet in length.
The success of Newton's telescope provided a brilliant confirmation of his theories of light and colours.
But Newton's work at Cambridge was about to be interrupted.
In 1665, an epidemic of bubonic plague engulfed London. And as there was a fear that it would spread across the whole of England, a quarantine measure was instituted, and all the Cambridge students were sent home.
But his time wasn't wasted. The following year, back home at Woolsthorpe Manor, Newton had his famous encounter with an apple.
And so it was, he found himself on the brink of a discovery that would change the course of science forever. Isaac Newton went home to Lincolnshire, and there he'd commence a process of discovery which was to guarantee his scientific fame forever.
This period, spent at home at Woolsthorpe, was to mark the beginning of what was to become known as Newton's Annus Mirabilis, the Year of Miracles. During this time, he continued his work on optics and even devised the theorem of calculus. But it was his brush with an apple that was to inspire his finest moment.
Are you sitting comfortably? Then we'll begin.
Whilst the story of Newton's discovery of gravity is almost certainly something he made up to make himself look clever, it has nonetheless entered folklore. Who knows what the young Isaac Newton was really thinking that day as he sat in the orchard at Woolsthorpe Manor? It's possible that science was the last thing on his mind.
Chepstow.
Whatever the truth, the brilliance of his insight was this. When the apple fell to earth, Newton was suddenly seeing stars. In a flash, he realized the force acting on the apple was the same force that held the heavenly bodies in place. And when he eventually came to, he would devise his famous law of universal gravitation.
The force of gravitational attraction between two objects is in inverse proportion to the square of the distance between their two centers.
Newton expressed his laws in mathematical terms, but essentially he stated that every object exerts an attraction towards every other object, and the heavier the object, the greater that attraction, whilst the closer the object is, the stronger its pull. This discovery was simple but revolutionary, and he published his findings in one great volume.
This is an original copy of Isaac Newton's Principia Mathematica, the mathematical principles of science. This is a pretty formidable volume, nearly 500 pages of detailed mathematics and geometry. You may wonder how long it took him to write it. In fact, it took him little more than 3 years to produce this extraordinary work. So many of the terms that we now take for granted were introduced into scientific parlance for the first time. Action, reaction, inertia, force, and all of them pertained to one great and predictable mathematical law, the law of universal gravitation.
It was universal because it applied to everything. Using it, Newton was the first person to explain why there are 2 tides a day. He realized that the gravitational pull of the moon draws the water on the Earth toward it, causing a mass of water to gather at the point nearest to the moon. Meanwhile, another mass remains at the point furthest from the moon, where its pull is weakest. This means that the sea is deepest at 2 points, where it is closest to and furthest from the moon. Since the Earth rotates every 24 hours, any given point will pass through high water twice and low water twice. Newton also went on to explain how the combined effect of both the sun and the moon produced the spring and neap tides. And there was still more to come.
Using his laws of universal gravitation, it became possible for Newton to predict with an incredible degree of accuracy the movement of the planets.
He realized it was gravity which controls the orbit of the moon around the Earth, in much the same way that a piece of string holds a stone from flying away when it's spun around. What is more, his calculations finally explained why the orbits of the planets are elliptical rather than circular. This is because a planet's momentum leads it to overshoot at the ends of its orbit before gravity brings it back again.
The great beauty of Newton's laws is that they prove to be constant in every part of the universe, from the dropping of a piece of chalk to the movements of the planets themselves.
And what is more, even now these same principles are used every time astronomers plot the motions of the planets or astronauts travel into space.
How about that?
Newton's discovery of the laws of gravity made him famous. However, his work bore key similarities to the published researches of his bitter rival, Robert Hooke. But typically, Newton refused to acknowledge his influence. Moreover, Newton's famous 3 laws of motion also drew heavily on Hooke's work. Let's have a look at them.
Law number 1. Number 1.
The law of inertia basically states that an object at rest tends to stay at rest, unless, that is, an external force is applied to it. Pretty simple, really.
Law number 2. Number 2.
Now then, this is a little more complicated, so pay attention. It deals with force and acceleration. Newton states that the force of a body is equal to its mass multiplied by its acceleration.
Yes.
But basically, what he's saying is that if you apply force to an object, it changes speed and accelerates in the direction of the force. And if you push twice as hard, the acceleration will be twice as great. Whereas if the object is twice as heavy, it will accelerate half as much. Have you got that? Good.
Law number 3. Number 3.
The third and final law is a piece of cake. It states that for every action, there is an equal and opposite reaction. Basically, it explains why the white ball makes the black ball move. And of course, these laws don't just apply to pool balls. They apply to everything.
Yes.
Isn't that brilliant? Although Newton was convinced that his universal laws would apply to planets just as they did to apples, frustratingly, he'd never been able to prove it. But in 1684, he was visited by the young Edmund Halley.
Halley and Newton started to work together on the nature of cometary orbits and the application of Newton's theory of universal gravitation.
Halley realized that if Newton's law of gravitation was correct, there was a particular comet which should return in just over 75 years' time. He made sure the astronomers across the world knew of his prediction, knowing full well both he and Newton would be dead by then.
In 1668, Isaac Newton returned to Cambridge, where he was given the Lucasian Professorship of Mathematics. He started to re-lodge in Trinity College and shared a set of rooms with a chap called Henry Wickens. Now, Henry Wickens later became a major source of Newton mythology.
Trinity College was said to be charmed by the absent-mindedness of its illustrious professor. At mealtimes, Newton would forget to eat, lost as he was in deep scientific thought. Working alone in his room by candlelight until the small hours, another myth suggests Newton invented the cat flap, which he installed in his study door. This story was later embellished, suggesting Newton had actually installed 2 cat flaps, one for the mother cat and a smaller one for the kittens. This may have been a myth, but what isn't a myth is that Newton, the great man of science, also spent 35 years of his life studying alchemy, the mystical forerunner of chemistry. Some scholars have even speculated that his depression in later life may have been caused by chemicals ingested while carrying out these peculiar experiments. His aim was to discover the mysterious secret of matter. But Newton's interest in alchemy was not unusual for his day. Many educated men were fascinated by ancient spirituality, and for Newton, spiritual matters were a key part of his thinking.
Although we think of Sir Isaac Newton as a scientist, we must never forget that he was also a deeply religious man. He was also one of the greatest biblical scholars of the age, concerned with dating things in the Old and the New Testaments. Biblical prophecy was absolutely paramount in his thinking. Isaac Newton never found human relationships easy, and there's no evidence that he ever showed any interest in women. Following the publication of Principia, however, in 1687, he became internationally famous and came to know many people. One of these was a young, brilliant Swiss mathematician by the name of Fatio de Douillet, and the two formed a rather passionate friendship, although almost certainly a completely celibate one. But when this fell apart in 1693, Newton was pitched into a deep depression from which he never fully recovered. During the time that scholars have come to call Newton's Black Year, he sent a collection of rather bizarre letters to his friends, to the famous diarist Samuel Pepys and the great philosopher John Locke. He wrote to Locke, "Why are you trying to embroil me with women?" What on earth was he thinking of? In later life, Isaac Newton became master of the Royal Mint, in charge of the nation's currency, where he earned a reputation for his relentless persecution of counterfeiters and forgers. In 1705, Queen Anne gave him a knighthood, making him Sir Isaac Newton, and at around the same time, he became president of the Royal Society. He went on to become a great icon of science across Europe, the most famous scientist of all time, it was thought, dying at the grand old age of 85 in 1727.
31 years later, on Christmas night 1758, a German amateur astronomer keeping watch spotted a small fuzzy star in the night sky. It was exactly where Halley and Newton had predicted a comet would return on its elliptical orbit around the Sun and Jupiter, and it slowly turned into a brilliant sight.
This was what we now call Halley's Comet. It was a spectacular vindication of Newton's laws of gravitation. The 17th century was the first glorious age of modern science. And Isaac Newton realized that light, color, gravity all obeyed one set of simple mathematical laws. It was the making of that discovery that turned him into one of the great and enduring icons of modern science. Good night. It was here, in the depths of the Brazilian jungle, that Charles Darwin was overwhelmed with the sheer diversity of life.
And a free specially presented set of information cards is available to accompany this series. To order yours, please call our order line number on 0870 555 5055 or log on to 5.tv/factsheets.